गोटा है. Let us discuss the conditions of hybridization. What are the conditions required for hybridization? There are three important conditions required for hybridization. Three major important conditions. Unless three conditions are satisfied, no successful hybridization can take place. One is the orbitals of same atom undergo hybridization. That is carbon, chlorine, nitrogen, oxygen orbitals take part in the hybridization process. No hybridization can take place between the orbitals of carbon and chlorine, nitrogen, oxygen. That means different atoms. The orbitals of different atom cannot take place in hybridization. Similarly, in biology, the hybridization takes place dog, man, elephant. No hybridization can take place elephant, man, dog, man. Similarly, in biology, the hybridization takes place in between same species. Similarly, in case of chemistry, the hybridization takes place the orbitals of a same atom undergo hybridization. Second, the energy difference in between the hybridizing orbitals. That means the orbitals those are undergoing the process of hybridization must be energy difference must be negligible. That is, their energy be nearly equal or equal. If energy difference is high, then no successful hybridization can take place. Hence, for this reason, the 2s orbital of a atom cannot take part in hybridization with the 3p orbitals of same atom. That is, 2s orbital of a atom cannot take part in hybridization with the 3p orbitals because the energy difference between 2s and 3p is high. Only the hybridization can take place the 2s and 2p who has negligible energy difference. There is definitely energy difference, but this difference is negligible. That is, the energy difference in between the hybridizing orbital must be negligible. Third one, the orientation. The orientation of the orbitals undergoing hybridization must be same. If orientation is not same, then no successful hybridization can take place. That means if one orbital is xy plane, then another orbital must be xy plane. If one orbital is yz plane, then another orbital must be yz plane. That is, the orientation of the orbitals must be same. These are three important conditions required for a successful hybridization. Let us discuss the characteristics of hybridization. Characteristics of hybridization. First, the number of hybridizing orbitals must be same with the number of hybrid orbitals. Number of hybridizing orbitals is equal to number of hybrid orbitals. That is, the number of orbitals take part hybridization will give the same number of hybrid orbitals. That is, if 2 orbitals take part hybridization, we will get 2 hybrid orbitals. If 3 orbitals take part in hybridization, we will get 3 hybrid orbitals. If we get 4 orbitals taking part in hybridization process, we will get 4 hybrid orbitals. That means the number of hybridizing orbitals must be same with the number of hybrid orbitals. Second thing, the energy of hybrid orbitals are equivalent. That is, the hybrid orbitals formed are of equivalent energy. The energy difference between hybrid orbital is very negligible. The energy is equivalent. Energy of the hybrid orbitals are equivalent. Third, the hybrid orbitals are more stronger than pure orbitals. The hybrid orbitals are more stronger than pure orbitals. Therefore, the bond formed from the hybrid orbitals obviously will be stronger than the pure orbitals. The strength of orbitals, hybrid orbitals, is more stronger than the strength of the bond formed from the pure orbitals. Fourth, it is not necessary to have electron in the hybridizing orbitals. In case of carbon, we find that the hybridizing orbitals contain one electron. All four orbitals are half filled, but it does not mean that in all cases the hybridizing orbital must contain one electron. That means the vacant orbital can also take part in hybridization process. The vacant orbitals having no electron can take part in the hybridization process. Fifth, the orbitals of same atom undergo hybridization. The orbitals of same atom undergo hybridization. This is important point. The orbitals of different atom cannot take part in hybridization process. Let us discuss the types of hybridization. Types of hybridization. Types of hybridization. There are so many types of hybridization. Let us discuss one. One is your sp3, second is your sp2, third is your sp, fourth is your d2, sp3, fifth your dsp2, dsp3, sixth your dsp2. First is sp3 hybridization. That means one s orbital and three p orbitals, that is px, py, pz, and take part in bond formation, giving four hybrid orbitals. This is sp3 hybridization. Second, sp2, that means one s orbital takes part with hybridization with two p orbitals, that means px and pyz orbital, giving three hybrid orbitals. Third is your sp, that is one s orbital and one p orbital, only one p orbital, that it may be px, py, and may be pz, take part in bond formation, giving two hybrid orbitals. The another type of orbitals in which the d orbital also can participate in hybridization. that is d2 sp3, that means 2 d orbitals and 1 one s orbital and 3 p orbitals, giving 6 hybrid orbitals. This is called your d2sp3 hybridization. Next is your dsp3, that means 1 d orbital and 1 one s orbital and 3 p orbitals take part in bond formation, giving hybridization, giving 5 hybrid orbitals. And another is your dsp2, 1 d orbital, 1 s orbital and 2 p orbitals take part in hybridization, giving 4 hybrid orbitals. And remember one thing, the shape of different type of hybrid orbital is also different. That means the shape of sp3 is tetrahedral, sp2 is triangular planar, sp is linear, shape of d2sp3 is octahedral, shape of dsp3 is pentagonal, and shape of dsp2 is square planar. This is the types of orbital as well as shape of different type of hybrid orbitals.